Hello, good morning.
Good morning.
Good morning.
Good morning.
Good morning.
Welcome. Yeah, good morning. We are all welcome to the OWASP talks presented by OWASP Lagos chapter, which is going to be an interesting one this morning. We surely appreciate your effort that carving out the time to be with us this morning for this wonderful event. And we promise you that you are going to benefit a lot and it will not be a waste of your time this morning. OWASP Lagos is a chapter created from the OWASP Foundation. And what is OWASP? It is the Open Web Application Security Project. It's a non-profit foundation that works to improve the security of software. All of our projects, tools, documents, forums, and chapters are free and open to anyone interested in improving application security. That is what OWASP is for. And you can be part of this wonderful non-profit foundation. This morning, we'll be looking at two topics which are very essential. The first one is the change responsibilities in modern software development environments, which will be handled by Martin Knobloch. The other topic, which is IT security governance in application development, will be handled by Adesoji Ogunjobi. Martin Knobloch is a global AppSec strategist at Micro Focus, and he's here with us. The last time he was on this event, he took the topic Hackers Mindset, but today he's going to be taking us change responsibilities in modern software development environments. Martin is now part of our community. Martin, we are here for you. Please.
Thank you. So, can you see me full screen, or can I do anything to make it full screen, or is it good enough like this?
Yeah, I think it's good enough. From my own end, it's good enough.
Yeah.
Yeah, it's good. It's good.
Okay. So, welcome. Thank you, Jobe. Thanks for having me back. So let's see, go into here. So, change responsibilities in modern development environments. The thing with security is we have tried many things to improve. So, talking about myself, I'm with security for quite a while. And as you can see, like in the gray of my beard, it's more salt and pepper these days. I joined software development late 90s, last century. Makes it sound even more. And from software development, I became a software application security specialist. So I was reaching out, seeking for what can I do to improve the quality, the security quality of my software. And back then it was different. So this talk is a bit what I see has come in the past and what I see to be foreseen, the trends for the future. The first part, of course, you have responsibility and your code. I think these days, the 27-year-old senior full stack developer, I always use as an analogy of young, driven, and specialist people, they think these days code is everything you can upload to GitHub environment, right? In the past, we could say code must have grammar, whatever. These days, it's changed. Definitely, since we have infrastructure as code, there's more configuration files actually, but still, it is software. It is. I have a configuration file. I can upload it to GitLab. So therefore, people think it should be handled as software as code. And for responsibilities, it's everything you have the privilege of. You become responsible. I many times say, also for identity access management, with every privilege comes responsibility, and the same for with all privileges now with this developer-centric software development life cycles they created becomes more responsible towards the software development. You see that we move towards developer-centric environment. And actually we can also say maybe the developers are shifting more and more to the operation part. We try as security to shift left to early security involvement, and they kind of shift right towards to the operational time, the system organization, infrastructure as source. Okay, but the thing is, with responsibility, it's common experience. And I use this 27-year-old full stack developer not only as a joke. I have seen it many times. So when you become older, so I was quite old when I came to software development. I always had a career in mechanics. I was a mechanic for injection molding machines. I transferred to software development, being a self-trained developer. I was always in the end of my 20s, close to 30. And back then I was suddenly the oldest. And you see still the average age of software development hasn't changed much. It's still in the mid to early 20s, late 20s, early 30s. And that means actually the history knowledge is quite short. They don't know where things come from because you are in the current time. That's what used to. That's what they're good in, and that's what's really good. We need young people to push the frontiers because those are the help us conquer the world, to adopt new technologies. But they come with responsibility. Now you're not in your hobby project anymore. It's not for your cousin's bakery or whatever little web shop. It's now enterprise level software development requires enterprise level experience and craftsmanship. I believe whatever you do, when you know why you do it, you do a better job. I can tell you in certain roads to stick to the speed limit. But see, if you don't understand why the speed limit is there, you will think that, hey, there's no police, there's no change to be caught, pedal to the metal and speed. But maybe there's a kindergarten around, or maybe that it's for the noise, it's for other reasons. The moment you know why you have to do certain things and what is the benefit in the whole chain, in the context of the bigger picture, then you do a better job because you know where it comes from, you know where to go to, and you can improve it as well. The same for software development. Software development is out there very early. And that's quite funny fact that a lot of people don't realize is the first developers were female because computers started out in the Second World War where all the males were on the frontier fighting and the female were actually developers. So what we do in the software development life cycle hasn't changed much. We start with the requirement, we do some design, we implement it, we verify it, and then we do maintenance, right? And even the roles hasn't changed much. Some have become cooler names, but still, it's the business who has the backless money. They pay for the software, so we build what they demand us to pay. Then you have the architect who sees how it fits in your enterprise architect, in your solution architect, in your software architect, whatever architects there are. There's plenty of architects out there these days. Then there comes the developer, he writes the code. We have the tester who looks if the code does what the requirement demanded to do. And then we drop the application to operations who have to maintain it. Nothing changed a lot there. And then over time, of course, the processes distilled, and there are several processes, and most people the older people can recognize this process where it was very well written, documented, and worked out. We come from the time where documentation was extensive and software development was hard. We had punch cards, we have to write software, it has to be printed out, it has to do code review, it has to be on tapes and stuff like that. So the development cycle was very expensive. So all documentation is to make sure that the end product will be really, really good because you couldn't go back or you would have already wasted money. You can compare to the film industry when we had in the past the physical tapes and they shot like 20 meters of tape. When there was one little error, that's it. You couldn't cut it and return it everything because it was just too expensive. These days, with digitalization, you do it like 10 shots and you just delete the rest. You don't have the expense of the physical film material. It's the same for software development back then. So we had the same cycle. We go from requirements to design to implementation to verification and maintenance. But how we transition from one to the next step has done with documentation. Now imagine when every step has to be documented, how much effort it has to be to document all those steps. It was tremendous to keep them up to date. So if then in verification there was a question or maintenance or even as early as implementation, you have to go back to design, maybe even to requirement. Hey, the requirements team already is in another project or has been dissolved because the one goes to the other project, another one has left the company. And imagine over time to maintain all the documentation. It was a big pain in the nowhere. Yeah, this has been called waterfall. And that is where they tickle the documentation from one, cascading the documentation from one to the next level. It was not wrong. It's still not wrong. It just means that you have heavy documentation, very static way to approach. And of course, we know now that at the beginning of the project, you don't know everything you need to know at the end of the project. And the other thing is that in years-long work, we would develop something that has never been asked in the first place. I always compare it to the game telephone. So this is what you do in child's birthday parties, when we still had them. So you have a secret word you whisper in the first child's ear, and then they whisper from ear to ear the next child. And at the end of the chain, a word came out, you never put it in the chain. And that's kind of what the waterfall work. After years it had been developed, was the customer never wanted in the first place. And then if you were lucky, there was some security requirements. It comes in the party verification step. So you couldn't change it then back there. So a lot of those problems have been addressed by extreme programming, who was as old as 1996. It came to Europe like 5 years later. I don't know how it was in Africa, but it gave the answer to many of those problems because it was not a cascading waterfall. It was a repeating cycle. Still, and now suddenly in waterfall, we had the development team and everything we built, we throw over the walls to testers. They tested it and throw it back like it doesn't work. But with extreme programming, we had peer programming, user stories instead of functional documentation, acceptance criteria. When is this story successful? So developer and tester became friends. They were one team. We did the planning, design, coding, and testing, and team responsibilities. But still, where were the operations? In the basement, they were to reside, right? The people with the glasses and the checked shirts and the pens in the shirts. So it worked on my computer, it worked on my test server, but we dropped it down and they're like, what is this? So still, there was not the whole team approach. It was also very much development focused. Not much connection with business. Business didn't know how to react on that, how to act on that part. Yeah. But a lot of things that we have currently with Agile came from that time. Like, as I said already, user stories, just-in-time development, simple design, prototyping, pair programming, unit testing, continuous integration. Project feasibility, how critical it was. So there was a big step towards DevOps. In DevOps suddenly, and that's a big advantage, we integrated operations in the team. Yeah, and now we don't have a circle, we have an infinite loop. And the infinite loop comes as for the team has now also operational responsibility on the application. Now it's not a team that writes the application and the other team that does maintenance. No, because we know that application will always change over time. It's not build, deploy, forget. It's build, deploy, and maintain and continue development. So we have this infinite loop where the dev and ops become one team and they have cradle to grave responsibilities. Of course, we didn't go in one major giant step from waterfall to extreme programming to DevOps. There were many intermediate steps and they actually combine. And I see these times that people call them out but didn't really understand what they are about. So we have Agile was the first thing that distilled from extreme programming, I think 2001 or 2, if I'm not mistaken by the time. We thought, hey, wait a minute, this key factors, that's really, really important. So the focus on the process, highlighting change, and the emphasis about accelerating to make quicker delivery possible. And that eventually led to CI/CD, because if I have to do things more than once, developer to automate, right? And same is for operations. Good administrators, they don't run the same command line script every day or every week or every month. Or no, they automate, they script it. So therefore, CI/CD came up with all those eliminating the human error probability. So by automating, so they were not scripts, automation scripts, build scripts. So not I build, I deploy to test, I manually deploy to production. No, now it's automated. I submit my code. The code will automatically be built. Automatic code quality checks are in place. It will then push to the testing environment, unit testing, other stuff, dynamic unit testing, browser automation is also not new, will come up. Test automation specialists will replace the test automated tester. And then when everything is green, it will automatically be pushed to production, right? And now the last overall continuing thing is then the DevOps with the high emphasis on responsiveness. Yeah. So it's a natural progress. And I don't know. DevOps, Dev, whatever ops, you have no DevOps, Dev Test Ops, Dev, whatever ops, Dev SecOps. But they're only there temporarily because they have to go. They're only good enough. We don't have to measure them anymore. It doesn't say Dev Test Ops. No, developer operations should test. So that should be removed. But we have to put them in sometimes as DevOps to put emphasis on it. To be, hey, guys, don't forget, we do that for a reason. So there's a lot of information on this picture. So let's be step by step. And that's what I see what goes wrong many times. So the business, as I said, are those with the bag of money. And the first error is the business assigns work to the DevOps team. Yeah. So build this, maintain this application. And the DevOps team then goes to work and works in that DevOps lifecycle, build and deploy an application. So they have one team, the DevOps team. And then we have the security team. They're responsible for the security of what DevOps built. That's weird, isn't it? When you are responsible for something somebody else does. Imagine you get blamed for something that's not done where you have no influence of, no mandate. Yeah. So I said, the business assigned work to development team. Development creates this new cool feature, the new cool functionality in this application. And what I find sometimes, somehow, security finds out about it. New applications, it's different, but changes and continuous change. They go, hey, wait a minute, this was a bigger change. Maybe they have all this security toolkit in place, but now they find out, hopefully not on per accident, but in the process, and then test the application. That's three. They discover and break. Because security in that kind of company, maybe it's external, and you know how it is. The more findings, the better. You are an external security company, so you have to bash them. You have to find vulnerabilities. So that's what you do, right? So the security team does the security testing, they find vulnerabilities, and what they use to verify the security, they use the security requirements. I have more often, more standard than being an assumption, seen that there is a development guidelines, and there are security requirements or guidelines. How can that be? You have one team that the security requirements guidelines should be in the development guidelines. That's not through documents, because the security requirements and guidelines are managed by the security team, and the development guidelines are managed by the development team. We have two documents. Guess who is reading what, right? So the security, the hacker, then does the security testing, penetration testing. Sorry. And as I said, the more they find, the better. Then they have this really cool PDF report. They upload to CISO, whoever gets an assignment, hopefully internal, maybe external. Look, that's all I found. And the CISO can do nothing else than go to the business and say, stop, we found those issues. But it's already after deploying either to a very close release date or already in production. So what can business do? They stop, we don't do business for the next half year to fix everything. Most times they have no other chance than just to approve and accept the risk. And you can understand why this is a problem, right? So when is then security report goes to the development teams like, hey, fix this. Yeah, but there are always 2 sprints further. There are already new security issues in the document. Yeah. Okay. So, what are the problems with pushing left in DevOps? The pushing security into DevOps, so in between Dev and Ops. No, they should not be in between. It should be embarrassed. Should be entangled by them. First of all, more complexity. You never ever should add more complexity. We already live in a very complex time with complex environments. Yeah, security should be able to reduce complexity. Even the tools you're using should not increase complexity. A problem is the manual verification. Everybody is short on resources for development, but also for security. Yeah, we are outnumbered and we don't scale. Then we have to do the manual verification for everything we find if you do test automation. KPIs on vulnerabilities. The security team, the more they find, the better, and the developers, the less they're found, otherwise they get bashed. The message was, when I get bashed for something I could do wrong, I don't know about, A, hey, where does this requirement come from? And B, hey, if I don't tell them, I don't get bashed. So that's something I try to do. So it should be different. Offloading responsibilities. It's like, oh, I have this report here. Goodbye. Tools methodology. You know how many security tools you use? The more different findings you get, and they're not standardized. Actually, there's now a standardization for static code findings coming out there. How do I manage the third party? So maybe I have a process for my in-house developed software. Then I need another one for my external developed software, my dependencies. For the companies, maybe you're in a bigger corporation, and then you buy a new company, and they haven't done anything on security. So we go there again. Yeah, and there is always the security tools and dashboards. Currently, I see that the security teams have to maintain them. But the security team is not here to maintain application dashboards. They're here to verify and increase security. So that's a big problem. So how to solve those problems? The solution lies within DevOps. Yeah, they have the ability to do what we as security do. We have for security the best times now with DevOps. I hear things like, DevOps, it means make more errors, more vulnerabilities faster. Yes, if there's no security, if you have not trained, then it will happen. You just have to, unfortunately, many times we've taken the DevOps Wild West. Some people say, I'm a DevOps developer, I have all responsibilities, I have free choice, I can do what I want. Free choice technology. This is not how it works. You have your context. Even on agileness, you have the foundation on what you build. You're not building a bakery today and a bicycle repair storage tomorrow. You don't have to build an application that does our registration today and tomorrow it's the next social media application. You have a context, and the context is solid. And you have to make choices. Of course, you have to verify the choice, and you have to move to a maintainable system with all the cutting edge, but not jumping the cliff before you know that's a better version or it's well maintained. As I said before, it's enterprise development. So you don't have the full Wild West, because as I said, you want the freedom, you want to have this ability, then you have the responsibilities. So what do we need? We need one unified dashboard. Because when we have several dashboards, one for the business, one for the security office, one for the developers, how to keep them in sync? More system makes more complexity. Automation is key. Everything should be as much as possible automated. So IT the real time, the least human interaction on feeding the dashboard, feeding this common unified dashboard, the better. And the dashboard one time must give you the full software asset management. So I need to know, as a business, where are my applications? What do I have? Where are they? And maybe I can drill down. Maybe what is the bill of material? Because for the security, it's like, hey, maybe there's a new Heartbleed. So who is using this open source SSL library? I need to have a dashboard that helps me, and don't have to shout to the teams like, guys, who is using TLS? Still using TLS 2? I should know this by heart in the dashboard real time, and we can find them, feed them by automation. Yeah. It can then help also with compliance because you are in charge, you are in control of what's going on from security, and thereby you can measure maybe not for vulnerabilities, bash the development vulnerabilities, but enable responsiveness of the DevOps by helping them and giving key features on the time to fix. The quicker they fix, the better they are. Yeah, and even third-party applications you can then feed into this system. A holistic view on your whole software application stack. Okay, so what does it mean? That means that we all have to feed into it. So you see here above, before the above the DevOps team, you see this little fake security champion. We have tried, and I have seen many successes, but also have seen many failures with integrating a security champion in the teams. Success is that you can then come together, but the failure problem, the possibility of a failure is that he or she becomes the one who has to go through all the findings. It's she or he who now has to again explain to the team, no, don't use string concatenation to write SQL injection. I just learned this. It's not the one who has to then see, oh, the security team has a new tool. Let's run it and see the next hundreds of thousands of issues. Yeah, that's why it doesn't work. Security must be a quality attribute, and quality is what every craftsman cares about. And if you are a software security development craftsman, software developer, you also embrace quality, and security is part of it. Yeah. So the security champions, yes, I'm in favor, but unfortunately, there's a very big pitfall on abusing them, on frustrating them. Let's go back to one. So with the DevOps, with the maintenance, DevOps is good in applications, maintaining and hosting applications. So give this vulnerability dashboard to the DevOps teams, whoever team it is. Maybe you have an over team, those same teams that are managing the Jenkins, the GitLab instances, all those. They should be responsible for the vulnerability dashboard. It's an application. It's not natural to put it to the security team. Yeah, give the development ownership on it because they then have also the responsibility of it. And with the test automation now, they can feed into the system. Yeah, so they can integrate it in their build pipelines. They own the build pipelines. They own the vulnerability dashboard. So therefore, it's very easy and natural to link the both of them. Yeah. They have the build pipeline results being also updated and integrated with dashboard. That means also the other side, the hacker then can feed their penetration tests because now they have the hands free to do more useful stuff, and it will feed into the dashboard. So they can have the penetration testing, what they do frequently, or there's a new feature they want to test, they can put it in there. And then, of course, it means that the security requirements, there are not another requirements document somewhere that will be old and dusty and put in the recycle build, but it's an agile, available requirements that be then cut to the needs to the development teams. And it's also there. And the business has an oversight what's going on. What is the gain? The gain is for the development because it's the moment they write code, actually the moment you are in your IDE write code, like the Office document grammar check, is the first level of security testing. It's of course high level. There is no multi-file, multi-stage in-depth security testing, but it's an early quick feedback. The sooner the better. No false positives. Of course there will be false negatives, but there is no perfect world, but at least no false positive. So the developer gets real feedback. Hey, don't use this statement, or hey, this one is something to do. We have decided to use this one or this SQL wrapper. Yeah. So they have the early feedback and the continuous feedback. They always see where are my priorities because they see the trend already in security, so they can act on it. They are to do the sprint poker. They know the user stories, so they know. Hey, wait a minute, our security problem goes up. How can we solve it? How can we solve it? Maybe we should talk to the security team because they have no monitor and mentoring in their requirements. So they can see the trends as well. And they see, wait a minute, this team started this new application or they use new technology. And now we see with automation that SQL injection goes up or the cross-site release forgery or the patent mapping or the server-side injection goes up. So maybe we should look into technology. What are they doing? So you can go there, talk to them. It's like, hey guys, I see this trend. What's going on? What did you change that causes this trend to go up? Also, hey, I see improvements. How could you improve so quick? Can we share this information to the other teams? That's where the security champions come together, because they can be organized in tribes and they share information. Yeah. So the security team now has the hands free. They don't have to maintain this. They can now use it for what they need. Not to find SQL checks. SQL checks we can find very easily with static code analysis. As we can find cross-site scripting mostly, I mean the low-hanging cross-site scripting on test automation. So they can now take that heads and minds for the multi-stage and the functional security testing. Yeah. And they find out the information how to monitor or mentor the development teams. That means also for the security. So now the business has a real-time dashboard, the single truth they get, and they can put on strategies. They can say, hey, wait a minute. I see that this technology has a problem. Maybe we should upgrade, or maybe I have to ask the business that we have to go to the next version or upgrade the servers of whatever measure. So he can now be more in control and can make his strategic decisions, also for trainings, for example, based on real-time information. And then we also put the business at ease, because they see what's going on. They see development, they see improvement. They can now be happy because they see, hey, I don't have to accept risk I never heard about. They continuously see if the risk goes up, the risk goes down. They see how can be compliant. Yeah, this is the perfect happy world when they all work together. So how does it work? Here you see it starts with integrating. As said. Third thing is we don't write 100% of our codes ourselves, right? The code we write ourselves, we have static code analysis. And I know it has a name of being slow and cumbersome and all the false positives. But it's not a one-time off. And I will go that deeper. So we integrate and automate it. Yeah? For everything that's external comes into your application, your dependency, your frameworks, your libraries, we have software composition analysis. And there we have a big problem. Because just that a library has a vulnerability doesn't mean the vulnerability has any impact on the application because the way I use it. But still, we need to be aware of, hey, this framework is bad, or this library is known, or this version of the library, please update. Yeah? So the moment, as said before, you write software in your IDE should be the first level of testing. Second level of testing, the moment you upload it to your shared source repository, because then you can do more testing in deeper tests. And then the moment you have dependencies, yeah, it's in your build configuration file. So every source code software composition analysis tool uses your build files and repositories because that's where they reside. So we know where to get it. The moment you set it up, link your software composition analysis as well. The moment you deploy anything on any environment, even on your test environment, you can run your Dast application because it's now interactive. So all this test automation you have, and I told you that testers are kind of negated resource for security. The moment you have them in place, they run the test script, you can use Dast to listen into it, to give the Dast more value, not only just see, discover, and execute. No, see, listen with the test script being run, discover more, discover information, and then to test. Sorry. And then there's the next part. IaaS. The more, when you have a most production-like environment, you can use IaaS, in the active application security testing. That is currently where we not only passively look what's happening, but also proactively look in the VMs, in the runtimes. Not only we look at the runtimes and see how it behaves. So maybe we can see and detect any anomalies. That would go to the next level, runtime application security protection. And there's tools there as well. Problem is that I have heard that there are a lot of customers that are kind of hesitant to have external software that maintains and actually interferes with your runtime. That's a problem, of course. Yeah. And in the end, when we are beyond this, we can go step further. We can now add also the monitoring. Because as I said, it's not an end at deployment. Everything that we assume to be secure today can be broken tomorrow. For everything we thought, hey, it's a solid solution today, or a solid framework, there can be an exploit written tomorrow, right? So we have to continuously monitor and integrate. So on the test environment, on the other one. Just let me look quickly. So we have to implement and engage and enable all those benefits we have from the agile development process, right? From agileness, we need to change the ability to deliver from the automation for secure test automation and the responsiveness from DevOps. What does it mean? No, sorry. What does it mean? There's that knowing and understanding we never ever will be able to write 100% secure software that also will be maintained and understood be secure in the next release or a year from now. We have to be prepared, and that is actually enabling on building on the responsiveness of DevOps. So maintaining and controlling, because now we have a dashboard, we know our information. We can build our responsiveness up on. So we know what's happening. We know where our application endpoints. When I have this SolarWind exploit, when I have a library suddenly been broken, I can upgrade for a reason. It's not just all hands on deck and look and discover and run around. No, we know where is the hole in our defense, and we have to fix it. And then the dashboard can also help you to see how quick we are. And as the hackers now of the security, they don't have to do the reporting on the slow-hanging fruit over again. They can do the monitoring training. And maybe the development team says, hey, wait a minute, this is technology, I see a trend. As I said before, I see a trend coming up in a certain vulnerability category. So I see the trending coming up. It's like, oh, maybe I see two other teams. The teams can join together, can maybe look, I have this trend, but the other ones have the same problem. Maybe we can join a coffee break and have security, and then we talk about our problem, and security can monitor and help to verify what is the right solution. Maybe we have to write a new library for our internal application. Maybe we find some new open source library. Maybe we have to upgrade something. Or maybe this functionality is just not what our company's best appetite does allow. It can be also a solution. But then it's not just I think and I feel. No, we have a dashboard. We have a common truth. And we can show the business why you have to do certain cases. I have seen also with dashboard for benefits for trainings. We have so many times we waste time, money, resources, and frustrations on this mandatory compliance training, right? Then you get an external trainer, and I have been there, the same boat. He comes in and does an OWASP top 10 training. First of all, there is nothing as an OWASP top 10 training. There are trainings based on the OWASP top 10. But do they really help the developers? Or are they talking about all the risks? And maybe they explain it to you in the PHP. What does it help you when they explain in PHP, when you write C# code, right? What frameworks help you? And this is the same what we had in the past with PDFs. It's very nice to get a PDF with the OWASP top 10 in it. And they tell you all about the thing that's wrong. Oh yeah, you have to also mention 3 good things, right? And I feel them because the more is better. And we have to go away from this more is better on vulnerability finding. I want to not be able to find a vulnerability. That means I have to teach and tell. For this, but you also can link them. Maybe it's also nice that in your dashboard you can write. The hackers can make little movies to record, screen record, how they exploited a vulnerability. Because when I talk to developers, say, "Hey, if you have a tab napping problem," they never heard about it. So they have to Google and find it. Wait a minute, I'm here, I'm developing. Why should I now invest the time and resource in finding out how this works? Exactly. The security team, I had in the past, I said, when you exploit something, make a record it. And then you can, on the vulnerability dashboard, when they say, hey, I have this vulnerability, they can click a link, maybe internal repository, and they can see how the security guy or woman, how they exploited this vulnerability. So then they have an understanding what's going on. Why is the impact and what is possible? It's just not on a PDF, but on a dynamic and way on the vulnerability dashboard, with an hands-on, in their context, feedback and training. So actually, they don't do an annual training. You do continuous training, continuous improvement, not only for the source code, but your whole team. And then you can have benefits, maybe. You can say which team had the most fixes. Whenever we bash in security, we are known to the Ministry of No. We are known to make things more complex and more expensive. We have been known for not integrating or enabling in the security teams, development teams. That's not stop. We must become one team to join with them. And the only thing how to do it is to share responsibilities and therefore share abilities. They are the cracks when it comes to maintaining applications. They are the cracks on software development. You are the specialist on security. So your role should be mainly in testing, but also in mentoring and monitoring to enable and give them the right tools to improve their quality. Of course, I always always fun to use movie analogies, and I don't know if you know a lot of the regular movies. It's not the same popularity of everywhere, but you are the wizard security people. And wizards do all the metric. And I have seen many times that there comes this penetration test. Even if it's internal team that comes, they do from distance, or give me information, where's your application, what does it do? Thank you, I do the security test. And then they do the security black magic, and out comes a PDF that doesn't align anything with the application, with the developer. And then, wait a minute, you tested production? Yes, I'm 2 steps ahead already in my testing, my DevOps lifecycle. So you have to be early and you have to be accessible. When the development team is building something, with one dashboard, you know that's coming up because the dashboard has to integrate also on their feature request. That you know, hey, there's some big thing coming on. There's an epic they want to talk about. And it's even better when they know some certain key item, what I said with the security requirements fit into the dashboard. Hey, there's something they handle privacy data. Ask your average developer, do you know what PII is? Personal identifiable information. Do you know what GDPR is, or whatever regulation works in your area? They're like, no. A lot of security people have problems to understand it. Imagine the security people, development people. So the requirements will be very short checklists on what you should have there. And of course, as I always say, it's the same as when you want to try to learn high jumping. You don't put a bar on the world record. Actually, it's like 1 to 2 meters more than I'm high, my height. You put a bar where you first you have to find out where is my bar. And the dashboard helps you to identify the bar of the quality and security of your team. The first thing is to try to have the teams on the same level. With the dashboard, it captures a trend. And if the same level is there, then together you raise the bar overall for the teams. And as I said, because the trending and dashboard, all the teams are in there, sometimes team members change teams. They can take a system. They can look in other teams' trends. So they can see maybe, hey, we have this trending issue, or we have this new vulnerability thing come up. We can expand. We can then do these war rooms, come together as team, as tribe, with security as mentor and teacher, and see what is the problem, how to respond on it, and can we find a solution together. And I think that's the main reason for security we have to change. We have to learn together. I have seen many times that a developer the security guy has not a development background. And that's actually something that scares me sometimes. Because when they have no development background, they maintain now an application. They have no understanding on application maintenance, the right crappy code. I have seen scripts from software security people. It's really, really disgusting. So give the responsibility to them, early integration, and be one, be part of them. And you know, even more now than ever, it is hard to be one team because everybody works from home, definitely here in Europe or in America. But take the chance and be addressable. But pushing the responsibility of the dashboard, of the development, they become now responsible and become more able. I hope that helps you, and I'm open for more questions.
Yes, if you have any question, you can ask Martins now. Martins, thank you very much for your time, and you've actually allowed us or make us to understand that everybody in the team have a responsibility, the developers, the operation team, the security team, making up the dev security ops. So it's actually a teamwork, and everybody is required to follow his guidelines. So we really thank you very much. So does anybody have a question? You can feel free to ask. You can type your question.
There's a question in the chat. I see a question from Magna. So his question. So my question would, for a startup with no abstract program, where should I start? SaaS, DaaS, SCA? Ha! Very good question. Thank you for that. The first thing you start with code quality, because quality code is by default more secure for maintenance and in general. So that's the first thing. Have your code quality rules in place. And don't go to first SaaS, DaaS, SCA. Go with the OWASP proactive controls. It's a very accessible and common sense OWASP top 10 proactive controls, what they should do in a development lifecycle. Yeah, the OWASP proactive controls is first to start for the development team, what to have to think of, like validate your input, handle your output, stuff like that. It's very high level and very well explained. The tools, the SaaS tools, traditionally it will become first because you want to integrate it. But before you start with SaaS tools, start with software automation, the code quality. I hope that you have built automation, so you have to build pipeline. And the next thing is then to build on the build pipeline. So have a solid base. It's not flexible, it's solid. In repeatedly, when you have the build pipeline, then you can add security tools. But imagine when you add a tool, there is always this explosion on vulnerabilities. Because the first time, even if you didn't almost no lines of code, you get a lot of vulnerabilities. And then you raise the bar together. Yeah? So first, quality, most important thing. A repeatable process, like a build pipeline, common sense, the OWASP proactive controls, and then raise the bar together with adding tools. And I know tools are not cheap, they're expensive. They're open source tools, they're first base, and then you have to see how much you can do. Yeah. So it's a process, it's not a one buying solution. I hope that answers your question. Any standard tools you recommend as a vulnerability dashboard? That's the question. Yeah, there are some open source out there, and I just see that there's always have the dependent. How it's called? Defect Dojo. That's sorry. The OWASP Defect Dojo is one tool where we have a vulnerability management tool, and there's also the secure code box. It's another one that's a OWASP project that works well in that part. So the OWASP Defect Dojo, there also indicates more the security reviews. It's not an holistic. I used it for a previous company. So we had this as a common truth between development and security. So that's one, and the other is secure code box. I haven't looked into as much as I want to, but it's a very promising tool. So if you had to choose between any of the three, which one would you be the best opinion to start with? For the SaaS, DaaS, and SCA? SCA is not easy, and actually SCA is very easy on a low level to integrate. So that's a part of the code quality. So integrate, when you have a build pipeline, integrate the OWASP dependency check or the dependency track. That will tell you the dependencies, if they have known vulnerabilities, registered by the NVD. Yeah. So that would be the first one. It's like a low level SCA, software composition analysis. Then, of course, there are open source tools to start with as well. For set with code quality tools, already have some security tools, but they're not going into deep. So you never trust one tool for everything, even in the context of SaaS and DaaS. But then you have this quality tools, and you have OWASP web code, set proxy for security testing. You can integrate also. So yes, you have to build up. You don't want to use all artillery when you don't have the time and money, because every tool has to be maintained, has to be paid for. And I think, I work for a tool vendor, and I'll be frank about that. And I could say, hey, buy my license. But if you buy the license of the tool I work for, it costs a lot of money. You have to maintain it. And if you have a very bad experience, you will never love us anymore, because you waste your time and money and resources on that. So go slowly and improve. And then look which tool fits best to your development life cycle and to your technologies that you're using. There's another one is standard tools or software will you recommend dashboard? I answered that. SonarQube would be helpful with code quality, test coverage, and see some security tests, right? Defect Dojo. Okay. Yeah, SonarQube definitely is good for code quality. That's where they come from. I know they claim they have some quality, also security tests. I think they're more file level tests and not data flow analysis and stuff like that, if I'm not mistaken. And there's also, when you use GitLab, there are also some security tests. So take whatever you can find and grab, because you don't trust one tool. And then when you become more mature and more enterprise, then you have to also do a more enterprise testing. That's what I said. The developer writes code, they want quick response. Yeah, that's why these hip new tools are out there. That's very important for them. In that context, I write code, I want to see it now. It's like when you write a book. You don't want to see the spelling mistakes when the book has been printed and is in the shop. Yeah. So then the other side is this lower, different stream in the security, feeding the security dashboard for the same application would be then as I said, the quality test from when you look in production. Huh? They have the people on the production line, you have the people at the end who put the stuff in the box. They have to quick visual review. And sometimes, maybe every half hour, they take a product, they measure it, they very quick test, no false positives. And then you have QA steps in and takes the box aside twice a day and do a longer lasting, hour-lasting test. The same for software development. That's the enterprise security verification that you have in the end. Okay. SonarQube is fantastic. It's really good, Sonar, and that's so different, but you have to see also what to use the tool and the right expectation. Yeah. What's the sort of threat modeling? How often should it be done, and what is the best approach? There are really good, always talks about threat modeling from, what's his name? I'm really bad with names. Adam Shostak and Grant Unger. And there are many tools. So OWASP also has a game on this. It's called Cornucopia. And the gamification is key. So what you need actually is to want to have people with common sense look into it. And there are different approaches. What you want is that the team is alert when they need it. Because now definitely if you do DevOps, continuous integration, you write code continually. You don't want to have a threat model where I change the button from one page to the other page. I need a threat model. That will not work. It should be on the higher. So there should be a checklist. And I think they have that already in place. So on certain questions, if this functionality or sprint includes changes in verification in data or stuff like that, then a threat model is needed. And there are different approaches. So gamification, I'm really much a fan of gamification because then you're hands off the keyboard, everybody's together, and you have a different mindset, and therefore you will have better results. The other thing is, when I came for onboarding a team, I had a very good one I think 3 years back in Karlsruhe. I was in a developer conference, and one said the threat modeling, what he does, he takes the team, and the newest to the team, is it the youngest, because it's a mistake to take the youngest, the newest to the team, he has to explain to you the architecture and the components, how they work together. And the others are not allowed to talk, because if he hasn't understood it correctly, they made a mistake, not him, they, because it's apparently not well communicated. So that's the first level of onboarding to understand what they're doing. And actually, threat modeling is good, and there are many things in how it scales, but I think the most important is to have people be aware if something goes wrong. And this awareness you create by being available. So threat modeling is good, but it also creates more documentation, more cumbersome. So definitely gamification is good, and there are different approaches. So if you look for OWASP threat modeling, you find a very good talk from Grant Unger when he talks specifically about threat modeling and how to scale it and build companies. I think that's it.
I think that's all. I think we don't have any more questions for you. That was fantastic. We truly appreciate you, Martin, and we surely enjoyed you. And we hope that when we call upon you next time, you will surely come around. You are now being part of our community.
Thank you a lot. And of course, the presentation will be shared. I send it to you later.
If you want, yeah, if you want to hook up with him, let me share. Sorry, let me share my screen. Sorry. Trying to share my screen here. Yeah, that's his Twitter handle @NotBlockMartin. You can hook up with him. Then he's also on LinkedIn, so he's always ready to share ideas with you. He's a fantastic person.
That's my friendly face.
So, Martin, do you have one or two things to say before you go?
Yeah.
Do you have one or two things to say before you go?
Yes. So, as said, the question about the slides, I will send the presentation as PDF to Tinopi.
Yes, I will be expecting that. So I'm going to share it with people. So you can if you did not register, you can just drop your email on the chat area there. Then I will send you the material later.
Okay, thanks.
So Martin, it's time having you around. Thank you very much.
Thank you for having me again, and look forward for the next time. Have a good day and good luck to the next speaker.